Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Target Locked and it's by Timotab. And here are the rules. Normal Sudoku rules apply, which means place the digits 1 to 9 in every row, column, and box without repetition. We also have region sum lines, where box borders divide a hollow blue line into segments which have the same sum. So, for example, these three digits must equal the same as this one. This digit must equal the same as the sum of these digits, which equals the sum of that digit. And so, for an example, we could have something like 1, 2, and 4, and that's a 7. And that's allowed. And this looks like some sort of like a targeting mechanism where I guess we're locked onto a target with our scanners. So that's what the target locked means. And then the final rule is Renban, where a solid magenta line must contain a non-repeating set of consecutive digits in any order. So, for example, for this Renban line, you could have something along the lines of 3, 5, 4, and 6. And that works because these are all consecutive. 3, 4, 5, and 6 are all consecutive with each other, and there are no repeats. So, for example, if you had a 3 here, this would not be valid, even though they are consecutive. 3, 4, and 5 are consecutive. They do have a repeat, which is not allowed on Renban lines. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay. So, we know we have a 5-cell... Well, okay, let's look at a couple of things. This digit is the same as that digit, right? Because the region sum lines must sum to the same value, right? So this digit must sum to the same value as these two, which sums to the same value as these three, which sum to the same value as this one, which sums to the same value as these three, which sum to the same value as these two. So these digits are, for three unique digits adding up to another digit, it must be 6 through 9. Same here. This adds to that digit, 6 through 9. These digits must add up to the same value too, because they are separated by the box borders. These digits also are the sum of three unique digits, so this is 6, 7, 8, 9 also. Now, we have 5 digits, which is at minimum 1, 2, 3, 4, and 5, so that adds up to 15, which means these two digits add up to a minimum of 15. Well, the minimum then would be 6 and 9, 7 and 8. Or you could have 7, 9, or you could have 8, 9. Those are the possibilities for these two cells. Let's see. Do we have anything else that we can do? These Renban lines, specifically, well, this has to be at least 5, right, to be consecutive with the 6, 7, 8, or 9. This must be 1 through 6. Because it adds up to 3 digits, right? And the largest digit you can have there is 1, 2 with 6, adding up to 9. Same here. This is 1, 2, and 6, adding up to 9. These could be 1 through 8. 1 through 8. On this Renban is 8 cells long. So it would have to be the digits either 1 through 8 or 2 through 9. Either way, okay, so these digits are also 1 through 6, and these digits are also 1 through 6. This is consecutive with 1 through 6, so it must be 1 through 7 here. So this on this Renban, you have the digits at you have the digits definitely 2 through 8. Because of that, this cell sees all of these digits. And what digit can be in this cell then? It has to be a 1. So this is 1 because it will see all of 2 through 8 here, right? It sees all 8 digits on this Renban. So the 2 through 6 are eliminated. This 1 is only consecutive with 2, so this cannot be 2. This is at minimum. This is either 1, 3, 1, 3, 4, or 1, 3, 5, and it must add up to 8 or 9. Similarly, this Renban has the digits 2 through 8 at least, and then with a 1 or a 9. So 2 through 8 is eliminated, which forces this to be a 9, which makes that 9, which makes that 8. Therefore, this becomes specifically 1, 3, and 4. Which means this cannot be 1, 2, 3, 4, because this adds up to 8. This is 9. 9's only consecutive with 8, so this must be an 8. These must be the digits 1 through 8. Which means, and these must be the digits 2 through 9. So this can't be 2, 3, or 4 because of the 2 and the 3, 4 pair in the box. These cannot be 8 or 9. This can't be 8 here. 8 has to be one of these two digits. Also, well, we don't know about 9. This is 5, 6, or 7, which is only consecutive with 4, 5, and 6. If you have 3 digits that add up to at most 9, you know that 2 of those digits must be from the set of 1, 2, and 3, right? Because if you don't have 2, take the minimum you could have without 2 digits that are from 1 to 3. You have 1, 4, and 5 because you can't have more than 2 digits from 1 through 3. Well, if you try 1, 4, and 5, then you add that up, that's 10, which is not a digit, so that's not allowed. So these 2 digits must be from 1, 2, and 3. Where in this box is a 9? Cannot be here, cannot be on this Renban line, because, again, it eliminates all 9s from here. So it must be here, which means this Renban must be 7, 8, and 9. So this cannot be 7 or 8. This can't be 8, and this can't be 9 here. This can't be 8 here. Where is the 9 here? It has to be one of those 3. 9 cannot be on this Renban, or sorry, in this region sum line, because if it were, the problem is it would have to add up with another digit to add up to 9, so that's not allowed. So it can't be here. Can't be here because of that 9, so this must be a 9 here, which means this cannot be 9. So where is the 9 in this box? Can't be here, can't be here, it must be here specifically, so this is a 9. None of these can be 9 then. This can't be 8. So this is either 6 and 9 or 7 and 9. Either way, this can't be 8. This adds up to either 15 or 16, which means it must be the digits 1, 2, 3, 4, 5, or it's 1, 2, 3, 4, 6. Either way, this is 1, 2, 3, 4, and then we have 5 or 6. We have a sextuplet in column 4, which eliminates 1, 2, which has to contain 1, 2, 3, 4, 5, and 6, which eliminates 1 through 6 elsewhere in the column. This can't be 2 through 6, so this must be 7. This can't be 7, so this must be 8, which means this can't be 8. These digits are only consecutive with these out of 5 and 6. And those are the ones we know have to be actually changing. because this is adds up to 15 or 16. The only one that can change is the 5 going to the 6. So this can't be 5 or 6. This can't be 5 or 6. We know this is 5 or 6. This is 6 or 7. Either way, the 6 has to be one of these digits. This 1, 2, 3, 4 can only be consecutive with 1 through 5. Therefore, we know this has to be 1, 2, 3, 4, adding up to, it has to be 5 because the rest of 1, 2, 3, 4 has to be here on this region sum line. So then this must be 4, this must be 5, which makes that 6, which makes that 7. This can't be 4, this can't be 4, this can't be 4. Where is the 8 in the central box? Cannot be here, so it must be here. This can't be 7 because of that 7, so this is 9, which makes that 7. This can only be now a 9. And these 3 digits add up to a 7, which means it has to be 4, 1, and 2. So these cannot be 2 or 4 or 7. This can't be 7. There can no longer be a 7 on this Renban. These add up to 16. Oh, and when I said 3 digits, you have to have 2 digits adding up to, at most, you have to have 2 digits in the set 1 through 3. It's actually at least 2 digits. But since we already had a 4 here, this 4 has to be with a 5 to be consecutive, which makes that this 4 makes that a 3, which makes that a 4. This can no longer be 5 here. This has to be a 7-9 pair because this adds up to 16, and only 7 and 9 add up to 16. This can't be 5, 6, or 8. This can't be 5 or 6, and this can't be 4. This can't be 5 or 6. This can't be 7, 4, or 5. None of these could be 4 or 5, and this can't be 4. So this can't be 5 here, and none of these can be 5 because one of these two has to be a 5 because this is 3, 5, or 6. So where are 4 and 5 in this box? They can only be here. So this has to be 4 and 5. Therefore, what can this be adding up to 9? It can only be 1, 3, 5, and 2, 3, 4. So either way, 6 cannot be here, and 3 does have to be here, so 3 cannot be here. One of these two must be a 3. Because we have a 1, 2, 3 triplet in the column. And where is the 3 in the column? It must be one of these two cells, which eliminates 3 from being here. This can't be 9 anymore. It can't be 7 or 8, actually, either. So this must be 1 through 6. This is 1 through 6, but it can't be 4 or 5. We know where is the 2. The 2 on this Renban cannot be any of these 5, so it must be here. So this can't be 2. Where's the 4? The 4 also has to be here. On this Renban. One of these is 3, one of these is 6. So 6 cannot be on the rest of this Renban. So we can remove 6 here. Where is the 8 on this Renban? It can only be here. So this is 8. And this is 3, 5, or 6, but we're not sure which. What are the remaining digits in this box? This can't be 7, so this must be 7, and therefore this is a 6, which means this can't be 6, so therefore it's 3. That forces this to be 5, and that forces this to be 6. None of these could be 3 or 5 then. These have to be 2, 4, and 6. This can't be 6. This can't be a 6 because of the 2, 4, 6 triplet in the box. This has to be 1, 3, or 5, but this can't be 5. Where is the 5 now in this box? It has to be here, which means none of these can be 5. This can't be 3 because of that 3, so this must be 1, which makes that a 3. This can't be 3. Now, where is the 3 in column 4? It has to be here. So this is 3. None of these can be 1. None of these can be 3. Why do I have so many 4s here? I don't know why I have so many 4s. I don't know what happened there. This cannot be 1 or 2 because of the 1-2 pair. Cannot be 3, 4, or 5. So this has to be 7 or 8 here. And the remaining digits in row 2 are 2 and 4. The remaining digits in row 1 are 1, 3, and 5. And the remaining digits in row 3 are 6, 7, and 8. Well, 2 can never be on a 4-length Renban with 6 or higher, right? The most you can have for 2 would be 2, 3, 4, and 5. So this cannot be 2. This has to be 4, which makes this a 2. So these two must add up to 9. So this must be 2. And that's another way of solving it. This has to be 2 and 7, which forces this to be 8, which makes that a 6. Again, 1 and 2 cannot be on this Renban because 1 only, the max, well, the only Renban for a 4 length that can be include a 1 is 1, 2, 3, 4. And 2 requires 2, 3, 4, 5 at maximum, and this was 6 at least. So this cannot be 1, cannot be 2, can't be 4 or 6, so this must be 5, which forces this to not be 5 or 1, because 1 is not valid again, so this must be 3. This can't be 3 or 5, so this is 1. This 3 means these 3 digits add up to 9 without a 3, so it must be 1, 2, and 6. So this is 1, 2, and 6. Therefore, 1, 2, and 6 cannot be in the same box, and this can't be 8 anymore. So this can't be 1, 2, this can't be 2, this can't be 1 or 2. This cannot be 1 or 3, so this is 5, which means this can't be 5, this is 4. This can't be 4 then. This can't be 4. We have a 3, 7 pair here. This 4 means this can't be 4, so this must be 5. This 5 means this is a 4, which forces this to be 2 or 3, which means this has to be 1 and 6. And the remaining digit we need on this Renban is a 2, so this must be a 2 here. These have to be 8 and 9, but it cannot be 8 here, so this must be 9, which makes that an 8. This can't be a 9 because of this 9, so this is 7, which makes that 9. Excuse me. This 7 can't be, forces that not to be a 7, so that's 3 and 7. This can't be a 6 because of that 6, so that's 1, and that's a 6. Oh, man. This can't be 1, so this must be 2, which makes that 1. Which makes that 2, which makes that 1. I'm suddenly coughing a lot. I don't know what's going on. This 2 means this can't be 2, so it must be 6. So this can't be 2. 6. This can't be 4, so therefore this can't be... This is a 4, so this can't be 4, so that's a 2. Which makes that a 4. This can't be 1 or 2, so this is 6. This can't be 2 or 6, so this is 1. This can't be 1 or 6, so this is 2. This can't be 2 because of that 2, so this is a 3, which makes that a 2. The remaining digits here are 1 and 6. These two digits must add up to 9, so if it's 1, this has to be 8. If it's 6, this has to be 3. And those both work, actually. The remaining digits in column 8 are 3, 5, and 8, but this cannot be 3 or 8, so this must be 5. This can't be 8 because of that 8, so this is 3, which makes that an 8, which makes that a 1, therefore that's a 6. And the rest we just do normal Sudoku. We've been doing normal Sudoku here anyways, but... Where can the ones be? We have 8 ones, so we know the last one has to be here. We have 8 twos. We know where the last 2 has to be. It has to be here. We have 8 threes. We know where the last 3 has to be. It has to be here. We don't have 8 fours. What about fives? We do have 8 fives, so we know where the 5 has to be. It has to be here. Sixes, we don't. We have 8 sixes, so we know where the last 6 has to be. It has to be here. We don't have 8. We do have 8 sevens. No, we don't. But we know where the 7 has to be in this box. Can't be here. It must be here. Which gives us 8 7. So now we know where the last 7 has to be. It has to be here. 8, we already have all of them. And let's just fill out the 4s then. This has to be a 4, which means we have 8 4s. We know where the last 4 is here, and therefore this must be a 9. And that's how you solve this puzzle. Yeah, so Ren bands are actually usually... I've seen similar things for these Ren bands. It's very helpful, actually, just recognizing what digits must be on certain length Ren band lines, right? So, for example, any 8-cell Ren band line has to contain the digits 2 through 8. Because the only possible combinations are 1 through 8 and 2 through 9, and those all include 2 through 8. So it's very useful in restricting those type of, well, just any cell, really. If that cell sees all the digits on a Ren band line. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.